Morning, everyone. Thanks for being here for my grand rounds. I'm Simon Su. I am one of the instructors in adult nephrology. And today, I'm actually going to be talking about something a little bit different than what you might expect in that it's not vitamin D or bone related. I had the recent opportunity to pen an editorial on air pollution and kidney disease. And what I learned was really fascinating. And I thought, what better venue to share what I learned with you all than nephrology grand rounds. So my only disclosure is that I breathe a lot of air. And so even with the shallow breaths that I'm taking, giving this talk, I can be expected to use about 100 liters or more of oxygen by the end. And so this talk is going to be divided into two parts. In part one, we'll talk about the basics of air pollution. I'll talk about the 6 most common air pollutants. Then we'll move into sources of air pollution, how it's monitored, and briefly summarize environmental and health impacts of air pollution. And that's when we'll move into part 2, where we'll specifically talk about what's known about air pollution in kidney disease, the role of air pollution in chronic kidney disease, plausible mechanisms of injury, its role in AKI, and wrap it up with some future directions. So the World Health Organization defines air pollution as the contamination of the environment by any chemical, physical, or biological agent that modifies the natural characteristics of the atmosphere. And these are the 6 most common air pollutants, and this is globally and in the United States. So the World Health Organization regularly reports on all 6 of these. And here in the US, the Environmental Protection Agency, the EPA, establishes air quality standards for each one of these pollutants. Particulate matter and ozone are the top 2 offenders of the 2 most widespread. So I'll spend a little bit more time describing each of these, but I think it's important to kind of cover the basics of each one of these 6 pollutants. So it may surprise you that particulate matter is actually not a gas. It is any mixture of solids or liquids that remain suspended in the air. So anything from dirt, smoke, metals, nitrates, and sulfates. And in the literature, you'll see them described in 2 categories. So there are coarse and fine particulate matter. Coarse particulate matter is abbreviated PM subscript 10, and all that refers to are particles with a maximum aerodynamic diameter of 10 micrometers. And so fine particulate matter is abbreviated PM subscript 2.5, and those are smaller particles with a maximum diameter of 2.5 micrometers. And just for reference here, the average diameter of the human hair is about 70 micrometers. And so when we're talking about fine particulate matter, you're talking about particles that are greater than 30 times smaller than the average human hair. And it won't surprise you to learn that the smaller the particle, the more deeply it can penetrate into the respiratory system. And as I'll demonstrate later, may even enter the bloodstream. So next we'll move into ground level ozone. And some of you may be thinking, isn't ozone the thing that we're trying to protect? And the answer is yes. Ozone can be either good or bad, and it's entirely dependent on where it is found in the atmosphere. So the good ozone layer that you're likely thinking about forms naturally in the upper atmosphere. And this is the ozone that really protects us from harmful UV rays. This is in contrast to the ground level ozone that I'm talking about here, which is bad ozone. It forms in the lowest level of the Earth's atmosphere, and it's entirely from chemical reactions between human-made pollutants and sunlight. And it's this ground level ozone, also colloquially known as smog, that has harmful effects to humans and the environment. Carbon monoxide, most of us may know as an odorless gas that's produced by the incomplete combustion of carbon. Major sources include vehicle exhaust, wood stoves, furnaces, gas-powered equipment, and it binds hemoglobin more strongly than oxygen, which is why you see the acute effects rather abruptly. Nitrogen and sulfur dioxides, they both result primarily from fuel burning. They're both associated with acute and chronic respiratory illnesses, and these are the 2 main air pollutants that really interact with water and oxygen to acidify rain, something I will touch on in a little bit. And rounding out the top 6 is lead. Lead, of course, a heavy metal that's used in motor engines, batteries, and radiators. And what you may not know, which I certainly didn't know prior to doing this, is that lead can actually get in the air. And in the US, it's primarily through metal processing and aircrafts that use leaded fuel. And while toxic to adults, it is extremely neurotoxic to children and newborns. So what are the sources of air pollution? They are traditionally classified under 4 categories, and 3 of which fall under the heading of human-made. And again, it may not surprise you to know that human-made vastly eclipses the natural causes of air pollution. Mobile sources, these are automobiles, cars, other vehicles. They account for 80% of all human-made emissions simply because of the sheer scale of automobile production and use worldwide. Then you have stationary sources, so factories, refineries, power and industrial plants. And kind of rounding up human-made causes, indoor sources, including cleaning products, print shops, and building materials. And then, as I mentioned, natural sources really contribute much less to the global burden of air pollution. I think forest fires ranks number 1, but you also have things like volcanic eruptions and dust storms. So air pollution monitoring can be broadly classified as into 2 categories. So regulatory air monitoring devices and non-regulatory air monitoring devices. And in 1970, the United States passed the Clean Air Act. And that's what really established these ground-based monitoring stations that are operated on the federal and local agencies. And so these ground-based stations are usually deployed in urban and populated regions to determine whether or not there's compliance with ambient air quality standards. And well, this is all great if you're using this to collect data or for research purposes. You may miss areas that are that could be more remote. And so many investigators have turned to non-regulatory air monitoring sources. And these include satellite-based remote sensors, which offer better spatial coverage. So NASA, for example, has sensors that can capture remote areas otherwise missed by ground-based stations. And so if you combine these 2 pieces of data, then you get better measurement exposures. And you also can have investigator-led monitoring campaigns. And I want to show you an example of this. So this is a study done by Dr. Christine Bay and her graduate student at the time in 2012. They were both members of the UW Department of Urban Design and Planning. And so they were just curious to see what are the air pollution exposure like through various bike paths actually around Seattle. And so there in the center, you can see Lake Union, off to the right there, Portage Bay. And so all they did was they mounted a mobile monitoring device for black carbon. Black carbon is a major component of fine particulate matter. Put it on a bicycle, and during the peak morning and evening commute hours, rode this 12-mile loop a couple of times. And they ended up publishing this report. So it doesn't have to be anything fancy, these investigator-led monitoring campaigns. So this is data from the EPA website showing growth areas and emission trends from the time the Clean Air Act was established in 1970 to 2022. And I think the main take home here is that while things like GDP, vehicle miles traveled, population, energy consumption has risen as a result of regulations and policies, you can see carbon dioxide emissions as well as the aggregate emissions for the 6 most common pollutants have declined over this time. So it would probably take multiple grand rounds to really do justice to the environmental impact of air pollution, but I really just want to give you some highlights. So of course, global warming. Black carbon in particular absorbs sunlight and is what contributes to climate change and the melting of the polar ice caps, etc. I talked a little bit earlier about nitrogen and sulfur dioxide, how it can acidify the rain. So this not only reduces the fertility of the soil, which again will affect the growth of vegetation, but also leaches heavy metals from the soil and together ends up polluting inland and marine waters, killing wildlife and fish. And lastly, infectious disease. So changes in climate also influences the timing, duration, and intensity of infectious diseases. And there are many studies linking climate change to and air pollution to the spread of epidemics. So now for the rest of the talk, I'll talk about the impact on human health. And this all began with the MEUSE Valley Fog of December 1930. So this was really a landmark event credited as the first scientific proof of the potential for air pollution to cause disease and death, which is really humbling when you think about it. It's less than 100 years old. And so the MEUSE Valley is this region in Belgium, which at the time was a heavily industrialized area. So lots of steelworks, zinc smelters, glass manufacturers, fertilizers, etc. And here in the map on the right, the pink areas are the densely populated areas in this valley. And so for a 5-day period between December 1st and 5th of 1930, the weather conditions were just right, so to speak, such that emitted gas from these factories really accumulated in this corridor between Liège and Puy. And as a result of this, hundreds developed symptoms and 60 were reportedly dead in the following 3 days. So again, this is kind of the first major scientific proof of the ill effects of air pollution. So since then, studies have really shown air pollution to affect pretty much every organ in the body, extending beyond the nasal, pharyngeal, and cardiopulmonary systems. And this is a figure that I adapted from the European Environmental Agency. And while some of the things on the left you might have been expected, the things on the right really surprised me. So air pollution has been linked with early onset Crohn's, things like fatty liver disease, impaired splenic metabolism of lipids, and even the bone and reproduction. So here in the bottom right corner, you can see all 5 of the 6 most common pollutants have been associated with impaired gametogenesis. And a lot of these mechanisms, including kidney disease, are still being elucidated, but they're pretty strong evidence that air pollution really affects all of these organs. So moving on into part 2, air pollution and kidney disease. So this is one of the first studies to really look at whether air pollution could be associated with reduced EGFR. And this was done in 2013 by a group of researchers in Boston. And by then, ambient or outdoor air pollution had been established as a risk factor for cardiovascular disease. And so these researchers thought, well, as highly vascular organs, the kidneys may also be affected. And so this is a cross-sectional study of 1,103 Boston area adults that were hospitalized for acute stroke. And these researchers just look at the residential addresses of these patients. And they used proximity to a major roadway as a proxy for air pollution exposure. And what they found is the closer that you live to a major roadway, the lower your EGFR. And that's nicely demonstrated in their main figure to the right, where on the x-axis you have the categories of distance to the major roadway in EGFR, and you can see that there's a linear trend here. Since then, many other studies have been done showing associations between various air pollutants and CKD. And these are just select studies that I found particularly notable and interesting. So Xu and colleagues in Jiazhen in 2016 did a cohort study. This was out of China. And they showed that long-term exposure to fine particulate matter was associated with higher odds of biopsy-proven membranous nephropathy. Bo and colleagues in Lancet a year later, over 2 million participants, and they studied 3 exposures, and they found that coarse particulate matter, nitrogen dioxide, and carbon monoxide, they're all associated with increasing risk of incident chronic kidney disease, EGFR decline of at least 30%, and incident ESKD. Bloom and colleagues study in 2020 showing that fine particulate matter is associated with higher albuminuria and also incident CKD. And the same year, you have a study by Paranjpi. And what they found was that fine particulate matter, PM2.5, is associated with increased risk of CKD, as was the higher risk APOL1 allele. But those with exposure to both had the highest risk. And so this study shows that environmental risk can interact with genetic risk to increase the risk of kidney disease. All right, so how could air pollution really cause kidney disease? Well, this was partially answered by a proof of principle study done by Miller and colleagues in 2017, a study that I thought was really neat. And so these investigators initially set out to identify mechanisms by which inhaled nanoparticles could contribute to cardiovascular disease. And in the process, we also learned something about how it may affect kidney disease. So there are really two parts to the study. The first part was in 14 healthy human volunteers. And so they put these healthy volunteers in a specialized, specially built chamber, pictured in the picture below. And they generated gold nanoparticles, and they basically had them inhale these for 2 hours while intermittently exercising. And their main results here are on the right. So on the x-axis, you have time after exposure, where they drew blood and urine samples. And the y are the gold concentrations. So you look at the far left, at baseline, there's no gold detectable in the blood, obviously. And then starting in 15 minutes, you already start to detect gold in the blood, such that at 24 hours, all the 14 participants had detectable gold in the blood. And in the red to the far right there, you see the truncated results of urine samples, where after 24 hours, all participants had detectable gold in their urine. And what's particularly striking to me is that these participants came back after 3 months. And what you can see is there's still a number of them where after 3 months after exposure, this gold was still detectable in the blood and the urine. So the second part of the experiment was in a mouse model. So similarly, these gold nanoparticles were administered to the lungs of apolipoprotein E knockout mice. This was done twice weekly for 5 weeks, and these mice are a model of atherosclerosis. And what they found was that the gold nanoparticles preferentially accumulated in inflammation-rich vascular lesions. So here in the picture on the right, you can see in the pink is atherosclerotic plaque, and the below up there, the little black dots are actually the gold particles that are embedded in the plaque. And so these sets of an experiment really showed for the first time that if small enough, inhaled nanoparticles can really penetrate the alveoli, translocate into systemic circulation, accumulate at sites of vascular disease, and become detectable in the urine, meaning that it comes in direct contact with tissues and vessels of the kidney. So I did a lot of reading on the specific mechanisms of injury, and I've kind of decided you can group them into two categories. Direct kidney effects of some of these pollutants, and then secondarily, mediation by comorbid conditions. And I'll talk a little bit about each one of these in more detail. So starting with potential direct kidney effects. So this is a simplified figure that I made really to summarize the results of experimental studies looking at direct kidney effects of particulate matter, which is the most well-studied. And so in experimental studies, particulate matter has really been shown to increase a pathway called the caspase pathway that can lead to apoptosis in human epithelial cells. And has also been shown to increase the amount of reactive oxygen species, which damages the mitochondria and leads to autophagy. So both of these are potential mechanisms by which, if they occur in the kidney tubular epithelial cell, for example, can cause kidney damage. There was another study that showed that particulate matter increases inflammatory markers, specifically interleukin-6. And this increase in inflammation was shown in this study to cause atherosclerosis in the pulmonary and cardiac vessels. And while they didn't specifically in the study see that the kidney vessels were affected in mice, I think theoretically it could still be possible. And so whether or not this is a process by which you can lead to glomerulosclerosis, that's something I think that should be tested in future studies. And lastly, in human mesangial cells, particulate matter has been shown to increase production of fibronectin. Fibronectin is one of the main matrix proteins that accumulates in the mesangium of patients with diabetic kidney disease. And so could mesangial expansion be why air pollution may cause chronic kidney disease? So moving on to mediation by comorbid conditions. So air pollution is convincingly associated with a few comorbid conditions, among them hypertension, diabetes, both of which we all know are leading causes of CKD in this country. And so this is a results are of a systematic review and meta-analysis of 100 studies, nearly 1 million participants. And it showed positive associations between long and short-term exposure to air pollutants and hypertension, as well as systolic and diastolic blood pressure. And this is just one of the tables. So you can see on the far left here, the air pollutant, and all except for ground level ozone here was associated with increased odds of hypertension, even after short-term exposure to each one of these defined as less than 30 days. So moving on to diabetes. So these are the results of a systematic review and meta-analysis of 17 studies, almost 4 million participants, and the main results here on the table to the right. And what you can see, they organized these studies by the air pollutants. Up top here, you have the nitrogen dioxide, underneath you have ground level ozone, et cetera. And over here on the right, the red diamonds here are just the combined effect of each one of these air pollutants. And basically you see that associations of nitrogen dioxide and ozone with diabetes were the strongest. This is another pretty important study in the Lancet Planet Health published in 2018. It's a cohort study of 1.7 million participants followed up for a median of 8.5 years. And again, the main figure here is on the right. So the gray bars in the background is just the histogram of the distribution of fine particulate matter exposure. But the red line is kind of the thing that you're interested in. The red line is the hazard ratio here. So you can see that with increasing exposure to fine particulate matter, you have an increased hazard of diabetes. And for reference here, the Environmental Protection Agency, the threshold for what they say is safe for fine particulate matter is 12 micrograms per cubic meter. So that's around here. And what you can see is even at these supposedly safe levels of fine particulate matter, that there's still an increased risk of diabetes with increased fine particulate matter exposure. And that leads us to air pollution and AKI. So this is one of the newest developments in the field. Wan He and colleagues in the Environmental Health Perspectives, this is an article that's been pressed, did a cohort study of over 60 million Medicare beneficiaries that were followed over a median of 6 years. And what they found was that long-term exposure to fine particulate matter, ozone, and nitrogen dioxide, they were each associated with increased risk of first hospitalization for AKI. And this was ascertained using ICD codes. And so it kind of really expanded the harmful effects of air pollution on the kidney to perhaps include acute kidney injury. And so that's kind of the old and new of air pollution and kidney disease. And it really opens the door for many future directions. The first are to identify the major mechanisms of injury that lead to chronic kidney disease. So I've shown you multiple plausible mechanisms of injury, but it's really unclear which is the leading type. And a second potential area for future directions, which is related, is to identify the major causes of air pollution-induced CKD. As we all know, there are multiple etiologies of CKD, and so which ones are the main ones that are induced by air pollution? is it membranous nephropathy? Is it through hypertension and diabetes? And those are things that are not known right now. With regard to the study that I just mentioned, we need additional studies that assess AKI and with increased granularity. You may know that using ICD-9 and 10 codes as outcomes is not sensitive. And they really undercount AKI and don't really specify the cause or the timing of AKI relative to the hospital admission. And once, if studies do show that there is a strong association, we have to identify the mechanisms of injury. A lot of the plausible mechanisms I showed earlier are chronic in nature. And so they don't really explain how air pollution exposure could really lead to acute injury. Is it that they increase susceptibility for AKI, or is it that they have direct cytotoxic effects, kind of like what we see in contrast? Those are things that are not known. Of course, we can always improve air quality through coordinated approaches between environmental and health professionals. So a couple take-home points here. Particulate matter and ozone are the most common air pollutants. Vehicle emissions are the most common source of air pollution in the United States and also worldwide. Most published studies, to me, convincingly show associations of air pollution with chronic kidney disease, and there are multiple plausible mechanisms of injury that need further elucidation. And lastly, air pollution may be associated with AKI, although more studies are needed to corroborate recent findings. I have a lot of people to thank. Of course, Ian DeBoer, my primary mentor and a co-author on this editorial, and Zhangzhao Bi is a postdoc fellow in environmental health and also one of the co-authors on my editorial. The awesome members of my mentor committee and Division of Nephrology, the KRI and Northwest Kidney Centers, without whom I would be unable to continue my work. Thank you, and I will take questions.
Thank you. Thanks for taking on this pretty harrowing topic. Yes, first question from Dr. Corella.
Hey, Simon, that was a really great talk. There was a recent publication about progression of IgA nephropathy in Chinese population, and air pollution was thought to be one of the major contributors. And you had mentioned that air pollution can also cause Crohn's disease. So maybe do you think there is some changes in gut microbiome and mucosal immunity that may be playing a role?
Yeah, I think that's certainly a plausible mechanism. Again, this is all pretty new. So air pollution, kidney disease, again, the first study was 2013, so it's less than 10 years old. And if you look at the potential mechanism, it really runs the spectrum, and inflammation certainly is up there. So I do think that that's very plausible and could be parallel mechanisms that causes, again, Crohn's and IgA nephropathy.
Thanks for the talk. Just had a question. Do you get a sense when you're reading through all these studies how difficult or easy it may be to separate exposure to air pollution from other socioeconomic factors, which are oftentimes associated with living in more polluted areas?
Oh, hey, Karen, you kind of broke up, but I think I got the gist of your question, which is how do you separate air pollution from other factors? Is that kind of summarize it?
Yeah, basically that. Yeah, air pollution is often associated with other poor socioeconomic factors, and how can those be divided out in these studies?
Yeah, it's a great observation. They can actually, looking at health disparities in air pollution and health outcomes, that's actually that's a big topic on its own, and what I ran into while doing this. And so Black and Hispanic populations, even when you adjust for things like income and level of education and stuff, they still show poor outcomes when it comes to air pollution exposure. And even globally, like third world countries also have poor outcomes. And I've seen enough that I'm pretty convinced. And like you suggest, it depends on the quality of data that are gathered. And in some of these big studies, I think they do a pretty good job of teasing out air pollution from other confounding factors.
Thank you.
I'm not sure if Dr. Struthers is able to be here today, but maybe in her absence, I'll put in a plug for Washington Physicians for Social Responsibility and volunteer her for anyone who has questions. Sounds like one of the, I think, easy to be a little fatalistic about some of these big issues. So one avenue of maybe taking some action.
Yeah, that's a huge thing, especially for a nephrologist to take on. But, you know, just knowing that automobiles and vehicle emissions are the #1 cause of air pollution. Doing things like taking public transportation or biking, I think, is a very reasonable first step.
I think you have agreement. So everyone here, make a few changes. Well, thank you. Thank you. Another compelling talk, and thanks to all of our speakers today. And everyone have a great weekend. We'll see you next week.